Next is homogeneous linear equations, where what you have to do here, the whole the equation is going to be in the form of x to the power of n d to the power of n y by dx to the power of n plus p1 x to the power of n minus 1 d to the power of n minus 1y by dx to the power of n minus 1, then plus so on. P n into y is equals to q of x. So where your p1, p2, p3, p4, so on, pn are real constant, and your q of x is going to be the function of x. This is known as homogeneous linear equation, where we have to substitute x into d, it's equals to theta, where your d stands for d by dx
Dear.
and theta stands for d by dz. So if it is in the form of x into d, we have to write as theta. Then x square and d square, it's equals to theta of theta minus 1, x cube d cube, it's equals to theta of theta minus 1, theta minus 2, so on. So on, x to the power of n d to the power of n, which is equals to theta of theta minus 1, theta minus 2, theta minus 3, so on, theta minus of n
N.
minus 1, right? And you're going to substitute your z is equals to e power e power e power z is equals to x, or your z is equals to log x. First you are going to change your homogeneous linear equation into the standard form, that is going to be into the theta form. You're going to reduce it into the, it's going to be either in the form of second rule or third rule or first rule. With the help of this substitution, x into d we can write as a theta, x square into d square we can write as a theta of theta minus 1, so on. If you are having x to the power of n into d to the power of n, that term you are going to write as a theta of theta minus 1, theta minus 2, so on, theta of theta minus of n minus 1, where x we can replace as e power z, or if z is there we can replace it as a log x, or if log x is there we can replace it is equals to z.
Z.
Get on the problem now. Solve x square d square minus 4xd plus 6 of y is equals to x square. Solution: we know that x into d, it's equals to theta, x square d square, it's equals to theta of theta minus
Theta
1,
minus 1.
and e power z, it's equals to x, and z is equals to log x. When you are going to substitute these values into the given equation, that given equation will get changed to x square into d square, you can write as a theta of theta minus 1, theta of theta minus 1, then minus 4 theta, then plus 6 of y, it's equals to e to the power of x is equals to e power z, x square e to the power of z whole square, so that you can write as an e power 2z. Simplify this one. What you're going to get? Theta square minus theta minus 4
minus
theta
4
plus
plus
6
6
of y. It's equals to e to the power of 2z, which is equals to theta square minus 5 theta plus 6 of y is equals to e to the power of 2z. Now it is got, reduce it into the standard form, where your q of x is equals to which term? It will
e to the
follow,
power of x.
it will follow into the which rule?
First rule.
First rule. In place of x, here you are having z. When you're writing your complementary function, you have to write it as a z, because your x has got changed to z. But later when you will write your general solution, again you have to change it to the x terms. First we'll find that auxiliary equation. What we are going to get? Auxiliary equation: m square minus 5m plus 6, it's equals to 0. M square minus 3m minus 2m plus 6 is equals to 0. M of m minus 3 minus 2 of m minus 3 is equals to 0. M minus 2, m minus 3, it's equals to 0. M minus 2 is equals to 0, or m minus 3 is equals to 0. M is equals to, m is equals to 2, m is equals to 3, where m is equals to, m is equals to 2 comma 3. The
3.
roots are real and
Real
distinct.
and distinct.
The roots are real and distinct. So your complementary function, which is equals to c1 e to the power of m1x plus c2 e to the power of m2x. Y suffix c is equals to c1, this should be z, sorry, m1z m2z,
Same.
e to the power of 2z, then plus c2 e to the power of 3z. Now we'll go for finding the pi. Find pi, where pi is equals to 1 divided by f of d into q of
Q of
x.
x.
It's equals to q of z, not x, z it should be 1 divided by, this is the formula, 1 divided by f of theta into e to the power of q to the power of
Q of z.
q of z, q of z, which is
Then
equals to 1 divided by whatever f of theta it was, theta square, minus 5 theta plus 6. Then
6
q of z is equals to what it got changed to? It
e
got 2z, e to the power of
2z.
2z. Here a is equals to 2. Substitute every theta, it's equals to a is equals to 2, which is equals to 1 divided by 2 whole square minus 5
0
of 2 plus 6 e to the power of 2z. 4, 10, 6 is a case fails.
0.
Yes, case fails. So what you have to do? You have to multiply numerator with
X.
z here. Multiply
Z.
numerator with z and differentiate denominator with respect to
Theta.
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 It's equals to z divided by 2 theta, then minus 5 e to
5.
the power of 2z.
2.
Again substitute. Again, substitute every theta, it's equals to a is equals to 2. It's equals to z divided by 2 into 2
4.
minus 5 e to the power of 2z. It's equals to z divided by 4 minus 5 e to the power of 2z, which is equals to minus z e to the power of 2z.
2 z.
Your pi, where your pi is equals to minus z e to the power of 2z. Now write the general solution,
Sorry.
where general solution is equals to complementary function plus particular
Here.
integral y is equals to y suffix c plus y suffix p. y is equals to whatever y for was c1 e to the power
C1
of
e to the power 2z
2z
plus
plus c2 e to
C2
the
e
power
to
of
the power of 3z
3z minus z
minus
e to the power of 2z.
2z.
Now what you have to do? You have to leave the answer in terms of x only. So what was your x? X was what? Therefore
F
x is
log.
equals to e power z, and your z was equals to log x. So your general solution will get changed to y is equals to c1 x square e power 2z. You can write it as x square plus c2 x cube minus z is equals to log x into x square. This is the required solution. Yes, Sharmin, any doubt over here?
No, ma'am.
It's a clear.
Yes, ma'am.